All right, so before, up to chapter 2, and we've talked about loops a lot in our pseudocode, well, we're going to apply them now, and we're going to take a look and see if we can actually get them to run in Python. So I have a couple of things open, and you can see my window isn't very exciting, kind of plain, but I do have our interactive or batch mode, and then we're going to have our place that we're going to create it from. So we're going to learn a lot of different pieces in this chapter. There's a lot of content in here. So one of the things we're going to do is figure out how we can do something with random numbers. We use them in a lot of gameplay, so I'm going to start out with this idea of let's figure out some random number pieces. So again, I'm going to always put in this at the beginning. I'm going to put in my name, something about the assignment, and I can use these all over the place. So this we're going to talk about, we're going to create random numbers. So random numbers, there's a lot of different types. The numbers we're going to talk about in here are really, we might want to call them pseudo-random. And so if you're in my security class, you're going to hear me talk about how using something like this where random numbers come out of a lot of code isn't necessarily secure because they're not truly random. So if you're going to start your own online casino while you're out here, probably this is not the way to do it, but we're going to start with this idea that we're going to create some dice. We've all seen dice. They have 6 sides. They're pretty tough. So we're going to do something first. And I've always thought this one's weird because we use it in so much of our coding. We're going to actually, this is the first time we're going to do something where we're going to import a library in. So by default, there's all different kinds of things in Python. And the random stuff I thought would have been one that's in there. But it's in a library we have to actually import. Well, I'm going to use the import phrase import. Notice it changes a weird color. And I'm just going to say import random. And when I do that, now that random library, all the constructs that are in this random library are available to me. Now I can use them and I can generate some random numbers. So just so I can mark this off, I'm going to say I'm going to randomly generate 6-sided dice. All right. So I'm going to assign them a value. So I'm going to call this one dice1. I'm going to say it's equal to, and here's where the weirdness comes in. So I'm going to say random.rand integer, and I'm going to say it's somewhere between 1 and 6. Well, I want to output this, so I'm going to print dice1, and then I want the end, I need some kind of an input to hold the program open. Kind of nice to use the new lines and move it down so it doesn't look as obnoxious. Press the enter key to quit. So I've got all my normal pieces in there. Let's see if this actually works. And I'm going to tell you it's probably not because I misspelled random up here. All right. So random integer somewhere between 1 and 6. So I'm going to run this. But when I run it, it says, oh, no, you got to save it. So I'm going to need to go find my folder. So I call it documents, and then Python somewhere, Python Spring 2020. And I'm going to call this my dice program, whatever I want to look at. Save it, and it's going to run, and I may have to adjust my screen just a little bit so you guys can see this. It's right on the flashing line of where it will show on the screen and where it won't. And it says, oh, it returned a 6. All right. Well, if I run it again, it gave me a 5. If I do it again, just out of curiosity. So That's really weird that it's giving me the 654, but not unusual, unfortunately. So I want to do something a little different. So I want to create a dice. I'm going to do dice 2. If you're in a casino and you ever run across a lot of games, so there's this very famous game, and it will allow you to create and roll dice, and you do all kinds of silly gambling things. So this time I'm going to do random again, but I'm going to do one called Rand Range. So it's a little different format. I'm going to say I want 6. So it'll give me a set of 6 values. Now, here's the problem with our dice. Our dice always start at 1 through 6, but the computer, remember, it always counts starting with 1. So I'm going to add a +1 so that it will also give me those totals. So now I'm going to do a couple of things. So I'm going to print dice 2, because I want to see what their individual values are, and I'm going to create a total dice 1 plus dice 2, and then I'm going to print total. And I'm not doing anything fancy, any formatting, editing, anything like that. And now I'm going to hit 5, and it says, oh, my dice are 2, 1, and 3. All right, well, that's kind of entertaining. So it shows us a few things that you can do. We can create a dice. Would I use 2 different methods? No, I would pick one. But they both do exactly the same thing. Oddly, just because of where I started and some of the things, I almost always pick the Rand Range, and then I add the 1 to it. We can show you what happens if we don't put that in there. Here, see what the chances are. It'll actually roll to 0, probably slim to none. But oh, it actually did. Goody for us. And you can see that it rolled to 0, and that wouldn't work. That's why we have to add that +1 to it. So, couple of pieces in there we need to make sure we look at. We have to have import the Rand range, or import the random function so we can use the Rand integer. So page 52 of your books talks about the Rand integer. Also looks at the Rand range function. Again, both results will do the same thing. So you're going to find that we do a lot of different things that are going to do very similar types of structures. All right, so we learned how to do the random range. Now we're going to do something. So watch, I'm going to copy this one just because I hate typing that line out. Control copy. All right, so I'm going to start a new one. I'm going to start a new program. Going to move it back over here. Wants to run away and hide. And I'm actually going to close this one so it's not in my way. So the next thing we want to look at is the if statement. If statements allow us to do a lot of really interesting things. Yes, I do want to save it, whatever. So they let us do a lot of interesting pieces, and so we're going to look at some if statements and see what happens in an if statement. So again, I'm going to start out with making sure I have some information at the beginning, and we're looking at if statements. And I'm doing something very similar to what the book is doing, but sometimes I will change things just a little bit. So make sure you've looked at the book, but also realize that that's not the only way we can do things. So in the book, it goes into a couple of details, and it's having you do some print statements about system security, where security is our middle name, and then we're going to get create a password where you're going to enter your own password, much like you would on a terminal at a computer. We're going to make a comparison, and we're going to see if we can make it do a couple of things. So onward and upward. So I'm going to do a print. Welcome to Top Secret Security. So the next piece I need to get your password. So password. We're going to set that equal to an input. And I'm going to put a text piece that will display, please enter your password. Alright, so now this is similar to what we did before. You've got a string called password. Well, now we're going to do a little bit of comparison. And I'm going to start my first if statement. So, and again, notice it changes color. So, if password, here's where it's a little tricky. If I use a comparison operator instead of an assignment operator, I use two equals. And so Python says, all right, I know you wanted a comparison. And the password we're going to use is, we'll just use the one out of the book, secret. So here is the step that almost everybody wants to mess up on. Make sure you have your punctuation at the end of that. When I do, notice when I hit enter, it moves in an indent. So everything's going to be in a text block indent. So these are the conditions and the things that are going to happen if it's true. So if you type in the word, whatever I used, secret, it's going to then do these things. So it's going to print, you gained access to the vault. So we can have it do anything we want to. Come back out to that outside indent. I'm going to put my input here. So it's going to do one of two things. You're going to hit this if statement, and it's going to say, all right, you gained access, or it's just going to go to the outside. So I'm going to save this. So let's do a file. Let's just do it this way. Yes. And I'm going to call this secret. It says, welcome to the top secret security, blah, 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 enter your password. And I'm going to say password. Doesn't really matter what it is. Notice it gets to the end and says just quit. All right. So now we're going to run it again. And I'm going to actually try to type in the word secret. You gained access. And so you can see that we're doing a couple of pieces in there. So if statements have a couple of pieces. We're going to expand on them a little bit. But this is a real quick example of that if statement. We can make a choice. We can do a binary decision. In other words, we can do if something is true, and we can also do if something's false. And we'll get to that here in just a little bit. On the bottom of page 54 is a whole note about this isn't really how we do it. First of all, if you type anywhere and it's actually showing you what you're typing, we probably have an issue. And this is certainly not code that is going to be vetted. The top of page 56 has a list of comparisons that we can use. So there's always the equal, not equal to, greater than, less than, greater than or equal, less than or equal. We do have to be a little bit careful of if we try to make a comparison of two things that are not equal. So, or we're not able to make a comparison. So if I try to compare my string of secret and I tried to compare that to 1, 2, 3 as a integer, it's going to say, oh no, you can't do that. All right, so the bottom of page 56 talks about indents. You have to have the correct indentation in Python. That's how it tells where blocks of code are running. So let me show you an example of that. So if I thought, hey, I need to also tell you, and I'm going to put this print line indented. So put in there, you're a wonderful employee. If I put it this way, so it's indented in this block, it will run when that condition is true. So let's see what happens. We can do this. And that's the only way we learn is by trying these things. And I know sometimes it seems silly. So if I write secret, it actually writes both of those out. So you gained access, you're a wonderful employee. If, however, even though it's on the same line, I have it indented at this base level equal to the if statement. And it's a pretty subtle difference. When I run secret now, it looks like it did the same thing. But that's, so let me show you what happens if I don't type in the right key. So notice it still did the "you're a wonderful employee," whether it's right or wrong. So that space, that indent, is critical to how we do that. So we're going to add one additional piece to this. We're going to add the ability to have a condition for both true and false. All right. So we're going to take this very similar code, "you're a wonderful employee." We're going to come back out here at this base level equal to the if sign, and we're going to type the key phrase else. And notice it turns orange, and once again we hit a colon, and when we come down it's in that indented. So I'm going to put a print statement here. You forgot your password again. Print. Should have you fired. So now in this particular case, we have if the condition is true, else, which is the end, and says, oh, if this part isn't true, if it doesn't hit here, it's going to automatically go to this else. So let's run this and see what happens. So please enter your password. Secret says you gained access to the vault. Let's try it again with typing in the wrong password and make sure the else clause actually works. I typed in the wrong thing. It says you forgot your password again. I should have you fired. So these if else, it really is a handy way that we can make a binary decision. So one way we can do this. Now, obviously, again, we are never going to take a password in this way. There's a lot of other things we're going to do, but I just wanted to show you how we can make this comparison between these two. So again, I'm going to close this out, and I'm going to do a file new. And we're going to introduce you to one more piece we can add in this if then else statement. In this case, I'm actually going to take some content out of the book because I don't want to write the ASCII art for this. So we're going to go through and we're going to look at a lot of this. It'll be very, very similar. I'm just going to do some copying and pasting. So somewhere, if you look under course documents, there is a folder in there that you can get. And that folder has a lot of pieces and parts and information. In fact, this is where I'm getting it right here, and you can see it. It's 3 source, and it's listed under course documents. You have to save it and then create it. And these are all the things in the book. Not necessarily for you just to have. You can have them. It doesn't necessarily make any difference. But you still need to go through them. But if you want to look at the code, this is a good place that you can actually do that. So I'm actually going to borrow this code right here, and I'm going to open it up in another editor. So over here, I have the entire code for this. I'm going to take pieces of it because I don't want to recreate and have to retype this. So in this particular case, once again we have mood computer. So I really need to put in my name. Trying to get everybody in the habit of that one. We import our random, just like we normally would. And we say, all right, I'm going to print a statement that says, I sense your energy. Your true emotions are coming across my screen. and then it's going to say you are blank, blank, blank. We are then going to pick a couple of random moods. So the mood is going to be dependent on this random number that's generated between 1 and 3. So we're going to have 3 moods. If that mood is equal to number 1, we're going to call that happy, and it's going to print a happy face. If it's equal to 2, we're going to print a neutral. Well, wait a minute. You said earlier we had a binary decision. Yeah, I did. Except Python lets us do something called an elif. So I can do a if, and then I can do another one that says elif, so mood 2, and then it's a neutral. And I can do an elif 3 and say that it's sat. Now, I've covered all my conditions at that point. I have 1, 2, and 3, and that's what I said we were going to create. What I'm going to put in here for this last one, because I'm still going to use this else value. So else is going to be used as kind of a catch-all. Holy cow, did I do something wrong? Let me see if I can get that all on the screen. Else says, if anything goes wrong in all the rest of my code, this is what it's going to be. And it's going to print out illegal mood value. You must be in a super, super bad mood. Ideally, this is never going to run. If I don't have a typo, if I've coded this all correctly, that will never, ever run. But it's a great way for me to protect my condition. So if I screwed up, so maybe I forgot and I didn't create this random right, and it actually generated a 0. So I did a rand range, and I forgot that the computer counts with 0. This would give me a way that the computer wouldn't crash, and the program wouldn't self-die, and we could figure out a way out of it. All right. So let's take a look at this and see what it looks like. So run. See if I can make it all run inside the screen here. And of course it comes over here. All right. So when this ran, it says, I sense your energy. Your true emotions are coming up from your screen. You are neutral today. Yeah. All right. So close out a few of these. So it ran, it did what we wanted to. Let's see what happens if we deliberately cause it to have an issue. So what I'm going to do up here is I'm going to just do some testing. So now I've eliminated that line, and I'm going to put another one in. I'm going to say mood equals 6. Now, we know that 6 isn't one of them that we can actually test for, but it's going to let me see if my error trap actually works. So F5, okay. I sense your energy. You are illegal mood value. You must be in a really bad mood. So it's a way we can catch and trap some errors. Okay, get it to click on there. All right. So I wouldn't obviously do that in practice, but it shows what could happen. And again, the most likely cause here would be I created it and I said, oh, I don't want to understand, or I missed something, or so. Here we have your true emotions in it, and it gave another neutral. So it's kind of a fun program, and it's in the book. I encourage you to try to type the ASCII and see if you can do that. It's a fun thing to do. They're a lot of fun. I don't want to spend your time online doing that. You guys will get bored. I'll get bored, and who knows what will happen in there. All right. So what do I need to move to next? And that is that idea of we need to figure out how to build a loop. So these were all fun. These programs all were fun, and they worked really well. But in most cases, I'm not going to do something one time. And the most powerful thing a computer can in most cases do is this idea of looping. In other words, doing something over and over and over again. It's where it's much better than we are. So I'm going to create another program here. And again, put my name in there. I am going to call this one 3-year-old. sometimes a 9-year-old. If you have children, you'll understand this, what's going to happen here. We're going to create a loop, and one of the things we're going to do is we're going to create a simulator for children. So print. So I'm going to tell you something about it. I'm going to say this is a simulator for children. Put a couple new lines in, get it down to the bottom. All right. So we're going to create our very first loop. The loop actually has to have some ability to get out of this loop. All right. So we're going to create a while loop. While, we're going to call it response. And we're going to use the not equal to. That's one that's a little different to get used to. And so as long as it says, well, response is not equal to because, then the following things are going to happen. So we're going to get response. We're going to use a assignment operator here. All right, so let me set up a couple of pieces here. All right. I also need to, so we're getting a changing this variable. We're changing response inside the loop, which we know we need to do. But I need a response, a value that's going into it. So the first thing I'm going to do is I'm going to set response then equal to just a blank. So blank when we go in here is not going to be equal to because, so it's going to force this to run at least once. All right. Yeah. We want to come back out. And then we're going to have our input at the end of this problem. So let's think about what's going to happen. We come in here. We're going to run this loop. And while response is not equal to because, it's going to keep asking why. Hit F5, see if I've typed anything really, really badly wrong. It's going to make me save this, so I'm going to call it child. So I have it saved somewhere. And it's going to want to run over here in a new window, so I'm going to move it over. All right. Why? Why not? And until I actually type it, exactly, including the period, including the capital letter, it's not going to let me out of that loop. That loop would run forever. Well, that's an example of a while loop. Probably a very simple example, but it gives us the pieces that we need to start writing this loop. So in the book on page 64 and 65, it tells you a little more about it. There is something called it's got a couple like almost Lego blocks or something, and it's called a trap in there. Make sure that you look at that. If I don't assign a value, I could end up with problems. So if I took this line out, most likely it's going to run, and it's going to run okay. But we don't know if there's a garbage value stuck there in response. And it's going to say, help, you're not defined. So that actually forces us to create a response in there. So this is a basic example of a loop. We could ask other questions. We could say, above this. We could even write more text. We could do all kinds of things. So my child, when they were 3 years old, came up with this statement. She repeated that for 5 hours, including stopping for a half an hour nap and popping back up in mid-sentence for "I want my cup." So I'm going to save it. I want my cup. I want my cup. I want my cup. I want my cup. And as long as I don't type in "because" with a period and a capital B, it's never going to end. So we can create, we're checking that sentinel value in there. We're saying, all right, we get a response, we're conditioning, we're checking it, and then we're coming out of that loop once that response is equal to the value or equal to our sentinel value. So page 66 talks about that sentry value and updating it. And then finally, on 66, we start talking about the idea of an infinite loop. All right. So if I have an infinite loop, I have something that never ends, and we have a problem with it, and it will just continue to loop. In this particular case, let's take this problem, and we'll take a look at it and see if we can change it just a little bit. If I eliminated this line right here, so I'm going to go out here, and I'm going to put my sentinel value is never going to change. I'm going to run a print line, and it's going to repeat that cycle over and over again. So let's try it and see what happens. One. So now, save it again. So we have actually ran something called an infinite loop. It's going and going and going and going and going, and it's never going to stop. Now, if you do something like this, I can stop it a couple different ways. Control-C will generally stop it. We use Control-C for a lot of things. It's a break. So if I do something silly like that, I can break it and I can stop it. Well, I'm always kind of interested, though. How fast is my computer going? All right. Let's do something where we're going to put in a value. So, equals value plus 1. And then we're going to print value. Handy way to do it. We created a value. We're just going to see what's going to happen in the middle of this program. So, F5. Oh, and we get that values not defined. So up here I need to say value equals, well, we know the first time it should be equal to 0, so I'm going to set it in that way. So you can see that computer spinning through those pretty quick. That's that loop. So within a few seconds I'm at 400, 500, 600. If you've got a toddler, you understand that all too well. We can do that a lot of times. All right, so the most common thing we do is we forget to alter that sentinel value. It's pretty easy to do. We put in, we think, oh, well, we've got a response, we're getting this. We forget this altering it in the middle of it. So infinite loops. There is an example in your book I encourage you to work through called losing something, isn't it? Losing force or losing battle. So there is another piece that we're going to look at. All right, so for now, I'm going to stop and we're going to send you another video hopefully tomorrow. So get you about halfway through this chapter and start looking at those loops. I am going to start on the next piece. I'm going to start on the Maitre D program, and we're going to look at some other examples and some other pieces in there and how we can create games and modules and other kind of fun things. All right. Make sure that you've done the discussion board. We're looking at sites that will help you. And hang in there, guys. Have a great week.